I'm R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we see the topic on inductance and inductors for the course Electromagnetic Fields and Waves. So before going to see the topic, we'll see the previous topic of magnetic boundary conditions. So this is the recall of the concept magnetic boundary conditions. So whenever there are two different mediums, magnetic mediums having different permeability, if there is a boundary, we need to have the boundary conditions in order to find out the magnetic field intensity and magnetic flux density. So the magnetic boundary condition, so we see two different components. One is the tangential component and another one is the normal component. So in the previous video, we have analyzed the need of boundary condition and also the behavior of the tangential field and also the normal magnetic field components. Now, coming to today's topic, the learning objectives. So, we are going to see the today's topic of inductance and inductors in design thinking way. So, the first part is the empathy part. So, empathy is the identifying the need. So, first we find out the inductance, understand its fundamental property of electromagnetic induction, and exploring different type of inductors, and we analyze the behaviors, and we use the concept of design thinking in order to understand it very easily. So empathy part. So inductance is the property of electrical conductor by which a change in the current flowing through it induces electromotive force, and in both conductor itself and also the nearby conductors. So based on that, it is classified as self-inductance and mutual inductance. So now the Faraday's law foundation for this inductance is whenever the current changes through a coil, it creates a changing magnetic field. So what happens is this changing field induces a voltage which opposes the change in the current, and this phenomena is called self-inductance, and this is defined in a mathematical way as induced voltage in volts Vi is equal to the inductance L into di by dt. So here t is the time in seconds, L is the inductance in measured in henries, I is the current in amperes. So next is the defined part. In the defined part, we are going to see the types of inductance. One is self-inductance and another one is mutual inductance. So first we see the self-inductance. It is the property where a changing current in a conductor induces voltage in itself. So it opposes the current changes, depends on coil geometry, so measured in henries. Next, the second type is mutual inductance. So when changing current in one coil induces current voltage in nearby coil, and this mutual inductance is the basis for transformers. Coupling coefficient is called as K, and a very important concept which enables wireless power transfer. Based on core material used, there are three types of inductors. One is air core inductors, second is iron core inductors, third is ferrite core inductors. In air core inductors, no magnetic core material is used, and this will be very useful in high frequency RF applications. This exhibits lower inductance but minimal losses. And second type, iron core inductors. So here the material used is ferromagnetic core material, which increases inductance significantly, used in power supplies and low frequency circuits. Third type is based on ferrite core material. So this ceramic ferrite material provides high permeability, and it is ideal for switching regulators and also EMI suppression. So, ideate part, we are going to see the factors affecting the inductance. The first factor is number of turns N. So, the inductance increases with square of number of turns. So, we can say that L is inversely proportional to 1 by n square. Here n is number of turns. And next important factor is coil area. So large cross-sectional coil area increases magnetic flux and inductance. Third factor is coil length. So shorter coils concentrate magnetic field, which increases the inductance. And the permeability, core permeability is mu, and the magnetic core material dramatically increases the inductance. So next is the prototype part. So now we see inductor behavior in circuits. DC circuits in steady state, inductor act as a short circuit. So during transient, it approaches the current changes. And the time constant tau is given by L by R. Next is performance in AC circuits. So in AC circuit, reactance is involved. So and it is called as inductive reactance XL omega L. So omega is 2 pi f. So we can write this XL value as 2 pi f L. So here the current lags voltage by 90 degrees. Higher frequency increases opposition. And energy storage. So it is useful in storing magnetic energy, and it is released when current decreases. So there are a variety of applications of inductors used in motor drives, which controls motor speed and torque. Next, useful in power supplies. So used in radio frequency circuits, transformers, and also inductive heating. So there are various applications of inductors in day-to-day life applications. So far we have seen the core concepts of inductance property, and also the inductor value, types of inductors, how the inductor stores energy, and the variety of applications of the inductors like transformer, telecommunications, energy conversion, and also filters. So summary, so far we have seen inductance and inductors, definition, foundation, types of inductance, inductor conclusion, factors affecting the inductance, behavior of the circuit, and also the applications. Thank you.